Hello there, it's Jay here from Jay's Vintage Junk, and today we're back looking at the Olivetti M250 motherboard. I've been doing a little bit of tinkering with this. What I've found so far is there was a lot, and I do mean a lot more corrosion on this board than originally. The first look over the board showed. It wasn't actually until I got some new glasses and really got down onto the board and also used an eyepiece like that to really look at it. I could see quite how corroded it was, and it's weird. I honestly do think this thing had been underwater at some point, because I've looked at the batteries up close, these batteries that were fitted, and there is absolutely zero, there is literally zero corrosion on them at all. There's none of the contacts are corroded. There's no sign of leakage whatsoever on them batteries. So I don't think the corrosion on this board, it could have had Vartas on here before they were fitted, they leaked. Someone just replaced the batteries and left it. I mean, then again, if that had happened, if that was the scenario, and then the computer had got wet, that'd explain a lot. Because the corrosion wasn't just localised to this part of the board, although this part of the board is far worse than everyone else. The corrosion had literally got everywhere on the board. I wish I'd have got some. In fact, there's a few components on here which I still need to re-go over, so I will try and get some close-ups on them so you can see how bad it was. But I must have gone through 30, 40 Q-tips trying to clean it off, and as well as that, like I mentioned in the previous video, there was like this residue all over the board, like a film over the board. Now, I've managed to probably get most of it off actually. What I ended up resorting to doing after watching some of Gadget's videos, I must admit, I've used vinegar before to neutralise corrosion around a battery and around like electrolytic caps that have leaked and stuff like that. But what I ended up doing with the board was literally, I've got my clear vinegar and a brush, and I ended up literally covering the entire board, not with the RAM. I took the RAM out because there was a lot of corrosion in the RAM slots. I literally covered the board in vinegar, and I left it a good 10 minutes and then started vigorous scrubbing around literally going round all the ICs with a brush. This is another one. If you, a lot of people, and I do as well, use toothbrushes for cleaning boards. But if you want something that's got a slightly longer bristle, say because you want to get like down in between places, you get a small paintbrush and just cut the bristles down. I've got them to about probably just under 20 mil, about 3/4 of an inch or around there. And this is brilliant for when you've got like I said, I've got the board covered in vinegar, literally going in like this and really get. And the interesting thing was, every time I did this and I agitated around the ICs, the vinegar just foamed up into a big foam all around wherever I was working it. So I'm sure there must have been alkali still on this board. I must have spent a good couple of hours going round it and getting the vast majority of the corrosion off. It does look a lot better than it did. Like I say, I'll get some. I'll try and get some close-up pictures so you can see quite some of the bits that I need to go over again, like round here basically, and some of the bits more like round here where I've these ICs here where I've actually cleaned up, and you can really see the difference. Like I said, I've got to go back over a few areas. The other problem is the corrosion has got under the silkscreen and it's affected the traces on the board. I haven't found a broken trace yet, but you can see the damage with your eyepiece. These, by the way, these aren't real eyepieces. I had a set of them like cheapy glasses that you get from market stalls, you know, that basically you have two of these on and they're meant to snap in place, and they were awful and they never worked properly because you could never get the two into proper focus with them. But actually, if you take the eyepieces off them and use these as an eyepiece for going in like that, they're bloody brilliant. This one especially because it's got a little light on it, so you actually switch a little light on like that when you're going in on the board. You have to get close, obviously, but it works really, really well for inspecting, you know, inspecting traces, inspecting vias and things like that. And basically what I've had to be doing is looking for all these corroded traces, and just with the continuity tester on the multimeter, just verifying them. Not made any easier by, this has got to be one of the most horribly routed boards I have ever seen in my life. I presume this was done on a computer, and it was very, very early auto-routing software, because it's all straight lines and 90-degree bends. There are no diagonal traces on this board whatsoever. Every single trace on this board is straight or straight with a 90-degree bend on it, which actually makes tracing really, really, really hard, especially considering that there isn't a massive contrast between the traces and the underlying board through the solder resist. All the vias are absolutely tiny as well. They are very, very, very small. All the traces are very, very, very small. So it's literally is just a case of going through and trying to find wherever we've got any bad traces. So basically that's what I'm at the moment, is going through, seeing if I can find any of the bad traces, because at the moment the board is still completely dead. The good thing is that at least I'm pretty certain now that corrosion, as in like round the ROMs and the RAM, are not a problem. I've cleaned all the pins on the BIOS. I've cleaned all the pins on the video BIOS there. I've cleaned the sockets the best I can, but in fact them sockets were in bad condition. It was just the 30-pin SIM sockets there were a bit green. But with the vinegar treatment, that come off. I'll go back to the vinegar treatment as well, what I actually did, because I mean, it's a bit more than just pickling your board in vinegar. So basically I poured the vinegar all over the board, let it soak for about 10 minutes, then went at it with the little stiff brush like that. I then went over it with, where have I put it? I basically rinsed the board using deionized water. So this is what you use for steam irons if you're in a hard water area, or you use to top your car battery up with. Great thing of this is it's got basically no contaminants in it which would contaminate the board, so it's just a good thing to get the actual vinegar off. So I rinsed the board down with the deionized water, then went in with isopropyl to get rid of the deionized water. I then literally hung the board on the washing line to dry, because it was a nice hot sunny day. So I literally left it on the washing line to dry, and then brought it back in after a few hours. And didn't try the board for about 2 or 3 days. I left it then in a warm area of the house in its anti-static bag. I actually sealed I didn't seal, but I shut the anti-static bag because I was curious to see if we get any moisture build up in there, and the board was already dry, so the board was absolutely bone dry. Before then I put the SIMs back in, I put the ROMs back in. Did try it again and we're exactly the same. We've got absolutely no activity on the board at all. So what I thought we'd do is we'd set up and just see whether we've got any life in it at all. I thought the best thing we could try is to see if we've got a clock on the 286 CPU. So what I'll do, I've not got a lot of room down here, but I think my little pocket oscilloscope should be good enough. It should at least show us that there's some activity on the clock pin, if nothing else. We can perhaps look around a few of the data lines and see, basically just have a quick scope about on the board and see if we've got any activity at all. It's concerning me that we don't even get so much as a beep or an error code or anything out of the board. So at least with the oscilloscope we might be able to see if it's doing something. So I'll just quickly pause the video and I'll get the old scope set up, and we can possibly have a look, see what the board is actually doing anything or not. So back in a sec. Right, we're all set up. We've got my cheap and nasty pocket oscilloscope. I don't even know what the bandwidth on that thing is. It's probably 10 megahertz if we're lucky. I mean, the CPU runs at 8 megahertz here, so we're not going to get, if it's 10, it could even be 5 megahertz, that little thing. I've no specs on it at all. It was under a tenner, I think. You know, it was dirt cheap, and I bought it many years ago. But it should at least show us if there's some activity on them on the clock line. So basically, I'll get you zoomed in a little bit. I'll see if I can zoom you. Yeah, that should do. So you can still see the you can still see that at this end of the screen there, can't you? Just about. And what we'll do is we'll go. We'll check the pins on the CPU. We've got the CPU here. Fortunately, it's marked on the silk screen, which is pin 1. So we've got pin 1 up there. And if you count down on the basically, you've got pin 1. If you count away from pin 1, pin 60 is on the corner here. So you've got pin 60 is A0. So you've got A0, A1, A2, and then the clock. So that's what 60, 59, 58, 56. 56 I think is the pin 56 I think is the clock pin on the 286. So basically we can have a quick look at those 4 pins and see if we've got any activity at all on one of those 4 pins, and see if anything on the computer is doing anything. I'll in fact, I might just squiz you up and just get you on the screen of the scope a bit more so you can have a see. Cause you don't need to see what my fingers are doing. You need to see what the screen of the scope's showing. So we'll switch the computer on, which is bloody awkward. Right, there we go. We've got the power supply switched on. And again, we've got no beep, nothing, no indication that the computer's powered, but the board is receiving power. And as the ICs do warm up, the CPU actually gets quite warm. It doesn't get burning hot, as in there's something obviously wrong with that hot, but it does get warm. Now, while we've got it like that, we'll start with the address lines, seeing they're easy to get to. So if we try A0, we just get a high. A1, we get a low. A2, we get a high. And the clock, we just get a steady high. So we seem to have absolutely no, we've got no activity on the clock, we've got no activity, well, you won't have any activity on the address bus if you've no activity on the clock. But yeah, we've got a completely dead motherboard. I have a horrible feeling it's probably to do with the corrosion. I think that we've got some either one of these vias or one of the tracks, probably somewhere in this part of the board, because this part of the board seems to be the part that is affected. The whole board was affected, but this is the part of the board that had was affected more than the rest. Anyway, what I think we'll do is I've got my little USB microscope out and a little netbook to run it on. So because I can't really show you through the eyepiece what I mean about how corroded the tracks are. So what I thought I'd do, if we set the little USB microscope up, I can actually get you down onto the board itself, and we can have a look a look at the damage, like in a bit more close detail. I'm just going to pack this little scope away so I don't damage it. I am planning on buying something a little bit better. My Fresnel scope I've got, it's up in the attic. It's I think it's a 15 or a 20 megahertz Fresnel scope. I mean, I paid very little for it. It were either a £5 or a £10 or something like that from a radio event I went to a few years ago. I said it was dirt cheap, but it needs a lot of work on it. Most of the sorry folks, just bear with me a sec. Sorry about that, folks. I get sick to bloody death of these cold callers. They really do get on my nerves. Anyway, where was I? Lost my train of thought now. That's the problem with these bloody bloody callers. Yeah. Anyway, so what I was saying. So if we get the little USB microscope in here, we can have a proper look at, well, I can show you some of the corrosion on this board, and hopefully eventually we'll find where the issue is, and I'm pretty certain that's what the problem is. I'm pretty certain we've lost a trace or we've lost a via somewhere due to the amount of corrosion that's actually occurred on this board. Right, what I will do I need, yeah, I'll just quickly pause you and I will get the little USB microscope set up. I mean, it's not very good, but it's better than nothing, and at least you can see close up what the actual issues with this board are, better than if I just get the camera right over here, because it does, I mean, it's a really cheap one, but it does actually go quite detailed. You can get some very close up look at boards with it. So back in a sec. Okay guys, we're back. Right, I'll just get you zoomed in. This software can actually capture. I've not played with it yet. I've literally just this is my old it's one my mate Andy gave me a while back, and I've been using it as just my downstairs little sit on the sofa and you know, go online kind of laptop. But I've just got one that's a little bit more powerful. So because this works perfectly, it's got a like 900 megaton processor in it. It's not very powerful. It can't really go on the web so much now. Any modern forums or anything, and it just it can't even do eBay. It just grinds to a halt. But it's absolutely perfect to use for stuff like this, with the microscope connected to it, my little logic analyzer, anything like that. It's perfect for. But as you can see, I'll just get you zoomed in, and you can see, I mean, it's only 640 by 480 this, but it does give you a really good look at the chips. This is one of the 7400 series. You can see where I've actually cleaned here. I mean, if you let me see if I've got something I can point with. Basically, I mean, where are we now? There we go. All these legs here, and this is a very small screwdriver, and you can see how much the magnification is. But all these legs here, you couldn't even see the legs for the amount of green corrosion that was on them. These have all cleaned up pretty much perfectly, and so I say it's using one of Gadget's techniques, which is clean the most of the actual corrosion off, and then clean your legs up. And I don't know where the hell I've done with it now, but basically clean your legs off with a little one of your little fiberglass a fiberglass pen. Ah, there's mine. So basically a fiberglass pen like this, so that I went in and I literally with the fiberglass pen cleaned, and I got the legs looking like this, like they're pretty much new again. I'll just go over to another part of the board where I haven't really done as much cleaning yet. It's had the vinegar wash and the scrub, but I've not actually gone in there with the little fibre pen and really cleaned up yet. And that is, if we get round you can see some of the what I'm talking about, some of the corrosion here as well. If we look at the traces here, can you see how discoloured they are? And that one's not been affected there, but then as you can see, as you come up, look how it is. And there are a lot, and I do mean a lot, of traces on this board which are looking like that, if you can see. Now we could have potential breaks here. I've gone through quite a lot around the CPU and not found a break yet, but like I said, as you can see, there's a lot on here which are in a pretty dire state. I'm not holding out that many hopes for this motherboard, unfortunately. It's looking a little bit grim. Let's see if we can just get over this IC. Try to figure out how to steer your mic. There we go. Now that one, as you can see, that's how it looks after it's just had the quick wash over with the vinegar and all been neutralised again. You can still see, the damage round the traces here. You can see the damage to the solder. But even this is better than it was. You couldn't even see these legs. It was just like green crust all the way around here. Like I said, all that's come off. I have been round here and tested most, when we've got a pad like that to via straight off it. I've done a lot of them around this part of the board, and again, I haven't found anything yet which indicates where the problem lies. But I'm pretty certain the more that we look at this board, well, if we just have a quick look over here, again you can see how bad. You can see where I've also tried cleaning some of the tops of some of the wires up. If we look at this one here, you can see this is what the fiberglass pen's done to bring it nice and shiny again. You can see these ones that need going over again. You can see how dull they are and where the solder's been attacked. And again, if you look at the copper traces here, you can see where the the alkalis got under the solder mask and started to attack them. You can also see what I mean about it's just all straight lines and 90-degree bends everywhere on the board. It's straight lines and 90-degree bends. Like I said, there's not a single diagonal anywhere on the board. Let's see if I can get you. There you go. You can see again how bad the corrosion really is. Look at this via here. You can see the damage around it. And these, I can't even see these with my glasses on with at the moment. The only thing I can see is obviously if I'm using the microscope like this or an eyepiece. And one of the biggest problems is it doesn't leave me a lot of room. I'll just zoom you out and just show you how close the microscope is to the actual board. You see how I've got the microscope set up there? It doesn't leave me a lot of room to actually get in there and do any actual remedial work. I mean, I'm on with my yeah. It's doable. It's probably doable, but it's going to be a hell of a lot of work. I'll get you back over onto the camera again. There we go. Sorry, it's a bit on an angle and what have you, but at least you can see what's going on. We'll carry on over the board a bit further. We'll try and just follow that wire maybe. That's not a wire I put on. That's a factory bodge wire. The other wire on the board is one that it was a factory bodge wire, but it's a wire that I've actually replaced. And that is, if I can get it, this wire here. Dear me, it shows how I don't like looking at my solder under a microscope. My soldering under a microscope. Well, it's a decent enough connection, but basically it's off the positive leg of that capacitor that I replaced, and it comes I used the thinnest wire that I had available. Even this is a bit thicker than what was used originally, but it's not too horrendous. And then it comes around to here. I'm just looking at that now. You can see where and that's where it went before onto the first leg of that IC. Is it I think it might be a I'm not sure. At first, let's see what that IC actually is. At first I thought it was 7400, but it could be clock generation actually. But could this be our problem? Have you seen this? We've got something going on here. So we've got, now, to me that looks like it could still be connected, but there's something going on there, isn't there? I think there's something going on there. Is that like a track could have burnt out? It don't look like it's corrosion. Oops. Get that back. It don't look like it's corrosion. It looks like something's happened there. I wonder if we just let's just have a quick look what that IC is, if we can with this. It's a Motorola part. 14011U, is that? Oops. It's really difficult. There we are. XAD950. So I'll have to look that part up. I wonder if that is to do with clock generation though. But where are we now? Look there. That definitely looks like there's something not right there. Let's get the meter out. And it's set on continuity, and we'll have a quick squiz at that, shall we? Right, I've got a meter on continuity. Right, now this is going to be really tricky to do. So we're on that pad there, and then if we've no continuity there, have we? There. So that track's broke. Look. I wonder. So what's happened there? That looks really weird. I wonder if I can just give that a quick clean up with the fiberglass pen, and we can see see if anything comes to light. I'll have to get the. I'll just have to swing the camera out of the way to do this though, because I can't. I'll zoom you. I'll zoom you out a bit further so you can see what I'm doing. But I'll just go in with the fiberglass pen, and I'll just see if I can clean that up a little bit. But it definitely looks like we've got an issue there. That's the first board issue I've found. I don't think we'd have found that if we hadn't have cleaned the board like I did with the vinegar and the scrubbing. So I'm just using a fiberglass here, so hopefully we've got no real chance of causing any further damage. But I would like to see what's happened there. Okay, that's the best I can do. Let's get the microscope back in and Well, apart from the fact we've covered absolutely everything in bits of fiberglass, but let's go in there with a cotton bud. We've got a Q-tip. Ooh, sorry about my big head getting in shot. Right, and where's the isoprop gone? Where's the isoprop gone? There it is. But I think we've at least got the first issue found. I'm sure it's not the only issue. I am certain it won't be the only issue. Let's just try go in there and there we go. Right, so it looks like, I'll just get you back over onto the screen. Eventually, like I say, I'm going to see if I can perhaps capture these from the record and then just put them into the actual into what we're doing. But does that to you look like that pad there should be connected to that pad there? So we should have a trace that goes down there and that pad be connected to there, because that looks like that's burnt out there, and there should be a little bit of a little bit of the print. The printing should be along there, the copper, and obviously you can see where that's blown up there. So there used to be a trace along there, but I think there used to be a trace there as well. So what's caused that? This is the really odd one. Something's caused that. And remember, we also had that blown fuse on the board, didn't we? And it would take quite a bit of oomph to do that to a do that there. Right. Let's do some basic tests again. Because we know that that pad there, that is connected to 5 volts, because it comes off the other side of that capacitor, which is connected to 5 volts. So that's probably what's feeding that chip. It's probably a bodge wire to feed that clock chip. Is something that's connected to, say, that pad there, shorted to ground? Could that be a problem? Let's try it. We've got no short to ground there. We've got no short to ground there. Just for curiosity's sake, I'm going to try. Was it a 12 volt line or a minus 12 volt line that we had the blown fuse on? And I've got access to it. Again, we'll just try and see if we've got a short, because we could have a short between power rails, especially if it's a minus power rail short into a 5 volt rail. That could do some nasty things. But no. But nothing there, and I'm on the I'm actually touching that the wire of that fuse that we bridged out. So there's nothing there. And there's nothing there. So I can't see any short like that. But I'm not 100% sure whether I'm just seeing something there or not. I can't be sure whether that pad should be connected to whatever's there. That one I'm certain that should be connected to that, because you can see the bit of the trace there blown up, and you can see a bit of trace there, so I can be pretty certain that used to go across there, and there used to be another pad there. But did that used to connect across there as well? That's what we need to. That's what I'm not sure about. It must be. There must have been let's try touching that pad there and see if we can get any continuity around there from it. So, this is really tricky to do, because up's down, left's right, in's out. Okay, right, we're on that one there, so don't move that one. Bring this one in. Can't feel anything there. You'd think there'd be something there. What I think we'll do is solder a wire. I've scratched the board there, that's a shame. I think what we'll do is we'll solder a bridge wire between that pad there and that point there. Have we got a wire going through to the other side there though? I'm not sure. We'll have to investigate that as well. See if we've got anything going through to the other side. Then we get some solder on it. We could just bridge it back. What I think I'll do is get a tiny piece of wire, solder it to there. See if I can solder it to there and then solder it back to that point there. Back to that point there. And we'll retest again and see whether we've got any improvement or not. So, back in a sec. Okay, we're back, and as you can see, I've got my bodge wire in place. I'm pretty sure, actually, that that pad there isn't meant to be connected. But you can see, it doesn't look very neat. But this was hard to do. I might if this works, I might attempt to redo it. But this was very, very, very tricky to do. But basically, I got one strand of copper wire. Tinned it up and managed to get it to solder there, and then bring it across and solder it to that pad there, and then break the excess of the wire off. Rather than cut it off, basically I made both solder points and then just twisted the wire at that point there until it broke free. I've done a quick continuity check and I have got continuity now. Basically keep them crossed, but we'll do another quick little test. And see if we've got any more progress, whether we get any beep or anything out of the computer now. So I think we'll just get the USB microscope out of the way for the moment, because we haven't got enough room to get that and the computer and everything in. Let me just get you. Zoom back out and over here. Right, so we've got the board. Don't think we're going to need that. I'll get the power supply. What have I done with the power supply? There it is. And we'll just see if we've made any progress at all by doing that. So connect the power back up. That's the power connected to the board. Let's plug that in. Right. I won't bother getting the I suppose we could plug some VGA into it just to see if we get any flicker on the screen now. I'm not actually expecting it to do anything, but I suppose if we get a beep out of it, it'd be nice to see if we're getting any video out of it as well. But we definitely had a broken trace there, and it's definitely at least that part of the trace. I'm pretty certain, like I said, that other pad doesn't go to it. It's just next to it. But we don't know. We can investigate that further. I really wish I had a circuit diagram or some service data for this thing, because working on it without it is very, very, very tricky. Let's have a quick look here. Let's get that over to PC. That's on PC it is. Like I said, I'm not expecting miracles, but it'd be nice if we just heard a beep out of it now. So let's give it a quick try. No. Ooh, I'm going to switch that off very quickly. I've left a piece of solder across the board. Don't think that was causing an issue though, but... And then nothing, no beeps or anything yet. No sign of any video or anything. I wonder if we've got any sign of a clock yet. In fact, I think we'll leave that for the next video. We'll get the scope back out and we'll see if we've got any more activity than we had on that on the 286 CPU. But what has occurred to me is we could have some damage down here now. If there's been a fault which has caused a trace to blow out like that, I don't think that was particularly a corrosion issue. I think something's actually happened to this before any of the corrosion happened to it in the first place. So we could potentially, I'm going to look up that part number, and I have a feeling that might have something to do with the clock generation. It's got a crystal right next to it, it's got these other two crystals very close by it. I reckon that this part of the circuit is definitely to do with clock generation. That could be a real-time clock chip. I'm not sure. We've got some, I think we've got some 7400 series logic, and then that U32 there, which again I'll have to look up the part number on. But I think the reason the computer is dead is because we've got no clock. We could have, like I was showing before, we could have other corrosion issues on some of the traces. But we've definitely found one fault already, which we've corrected. What I suppose I should do, really, is pull out the old logic probe. I think next time we have a look at this, it's going to be a scope and logic probe job, and we'll have a really good look around this part of the circuit with the scope and the logic probe, and actually try and see and figure out what's going on, because until we've got a clock running we're not going to get anything working at all. Anyway, I'm going to leave it there for now. I hope you enjoyed this little update on the Olivetti M250. So thanks for watching, and goodbye.